Hello and welcome to our presentation. We are so glad to present what we have done so far. And let me first ask this question. How many of you get lost in a building that he or she visits for the first time? Or what you will do if you need to reach a place inside a building but you don't know where that place is? I ask this question because our project is to design a visible light communication navigational system. I am Abdulrahman AlSaadi and my colleague is Saeed Alkindi. In this presentation, we'll go through an introduction, then we'll go to literature survey. Also, we will discuss the design and simulation and implementation. Before the last, we will summary what we have done so far, and the last thing is the conclusion. The aim of this project is to design visible light communication navigation system inside the buildings. After understanding, searching, and studying the visible light communication technology. The background. The visible light communication use light emitting diodes LED to send data by blinking at very high speeds that is not visible to human eyes. Visible light communication provides high bandwidth and immunity to interference from electromagnetic sources. Now let's go to literature survey. And in this part, we will talk more about visible light communication system based on research and studies. There are four main points in visible light communication system. The first one is position estimation techniques, which consist of time of arrival, angle of arrival, time difference of arrival, and received signal strength induction. The second one is a creation of indoor map data. Indoor map data are necessary to calculate and provide accurate position information, distance, and travel detection. The third one is compensated geometric sensing. Obtain the geographic coordinates from the visible light ID sent from an LED light. The last one is potential visible light communication application environments, and we will talk more in next slide. There are many applications where we can apply this system. For example, we can apply this system in museums, shopping malls, space stations, libraries, healthcare, warehouse and factories. Also, we can use it in government, defense, and hotels. Let's talk about design. We divide the design section into two parts. One part is for the circuit, which basically consists of two circuits, transmitter circuit and receiver circuit. And the other part is to discuss the digital map. Let's begin with the map. In indoor map navigation, we create a map for a building. This map consists of different rooms, baths, and all indoor area. The purpose of this map is to determine the movement paths. Indoor navigation. What we mean by indoor navigation is how a person will be able to navigate from one destination to the another using a digital map. In this part, we will show you the steps to make a digital map or interactive map used to navigate people inside the building. The first thing we must do is to assign the locations of the rooms, sections, and all other areas which belong to the building that we want to apply the indoor navigation in it. The second is to determine the appropriate places for the transmitter LEDs. As you can see in the picture on the right, we put 5 different LEDs in different locations, which will help to cover the whole area from starting point to the location that we assigned. We choose 3 different rooms to apply indoor navigation on it. For example, Office 1, Library, and Office 2, as shown in the picture. Also, in indoor navigation, we must define all possible movement paths, which will reach the selected rooms on the map. The navigation will start from a specific point, so we assigned a start point as you can see in the left of the picture. So now the process as following. When a person arrives at starting point, he or she will be able to use indoor navigation of the building that he or she located on. Then he or she will choose his or her destination. After that, the digital map will show a specific direction to the destination. For example, Office 1, Library, and Office 2. In the next slide, we will show you how the process of indoor navigation is done. So let's go and see. As you can see on the right, we have three different indoor navigation. The first image is for Office 1, and the second one is for the library, and the last one is for Office 2. If we choose one, for example, the destination to the Office 1. If a person decides to go to Office 1, starting from start point, the first thing he should do is to search for the Office 1 on the digital map, and then the LEDs will start sending their ID, which is the location of that ID, starting from LED 1 in this case, to guide the person to the next LED, which is LED 2, so and so until the person reach his destination. And the same thing will happen if we choose the other rooms, but the transmitter LEDs will be different. The digital map also can be used in smartphones, and it will be easy to use and helpful for visually impaired people to navigate indoor. Now let's go to Saeed to know more about the circuits.
There will be two circuits. The first circuit is about the transmitter, and the job of the transmitter is to send information to the receiver. And the second circuit is about receiver, and the job of the receiver is to receive information from the transmitter. Now, let me speak about the block diagram of the system. It is divided into two parts. The first part about the transmitter, and it consists keypad, microcontroller, and transmitter LED. And this is the second part about the receiver, and consists of the photodiode or LDR as a sensor of light, and consists microcontroller and LCD to display the output of the system. In this part of a presentation, we'll be speak about simulation and implementation. Now, let me speak about the transmitter circuit that is designed by using Phrygian software. The keypad is used as input in the transmitter portion of Li-Fi communication. That means we will use the keypad to pick the text to be transmitted. The information is then handled by the control panel, which is in our case is Raspberry Pi, that uses C code language to program. Raspberry Pi transforming the data into binary bytes that can be transmitted using an LED source. The data is then fed to an LED lamp, which emits a visible light pulse to the receiver. In addition, each input and output pin in this circuit determined for C code languages for the programming. However, the second part of the system is the receiver circuit. As shown, the LDR sensor receives visible light signal from the transmitter side and converted them into interpretable electrical pulses that are fed to the Raspberry Pi and the receiver circuit controller unit. This pulse is received by the Raspberry Pi, which converted into the real data and display it on LCD screen. The full system of visible light communication is shown in figure. The system is simulated in Freighton software, and it shows both circuits, transmitter and receiver of the system. Now, let me speak about the implementation of the hardware part in this project. The experiment was to prove that the LED are applied to transmit the data by blinking and received by photodiode, and it has been success. The input data from keypad is referred to LED ID, which decided the location of that LED. Now, when the LED sends its ID to the digital map, the map will be directly know where that LED is and then take the person to the next destination. The process is the following. When a person clicks on a number from the keypad, the LED will be light on, which is mean the data is sent to the receiver side and detected by photodiode. To ensure the data was received, the number that sent from keypad will be shown on LCD connecting to the receiver circuit, and the same thing will be happen to the receipt number. Each number take to a different destination. A summary of what we have done on this project are search, designing, simulation, implementation, and testing of visible light communication navigation system. In this project, we developed and tested the indoor